Hey there, welcome to the first suggestion video, where I take your ideas and build them into quick, focused tutorials. This video is going to be focused on two comments from Reddit. Shout out to Donut Man and Lucado. We're starting off with an arcade style scoring system. In the example shown here, you get a score based on how much you tap the red button during the timer, and then input a name. Based on your points, your name is put into the list of the top 10 scores. Any scores lower than yours are pushed down in the list. This is using a simple array function. This code here is all I'm using to edit the array, and this part is for an example setting a random score and name. I'll be using this text to illustrate how the code is working as I'm going through it. First off, we have tap name. This is the variable that stores the player's inputted name. For now, we're going to set it to a random one using the choose function. By doing choose, open brackets, and then a bunch of different names, it will just pick one at random. Secondly, we set the taps variable, which is just the number of taps a player got during their game, so essentially this is their score. In the example to the right, we hold two values on the X, the name and the score, and on the Y we hold different players. All arrays have 0 as their first number, so you count from 0. So the next part of the script does a loop from 0 to 9, and if any of the scores are lower than the new score, it calls the function addScore. So in the example to the right, we can see our player's name is now P and they've got a score of 50. So going through the loop we just discussed, we have to find where P would go in this list. This script only triggers if the score is less than your current score. So this script would check Jim and say 82 is not smaller than 50. Then it would check Cat and say 68 is not smaller than 50. Then it would check Pop and say okay, 40 is smaller than 50. In this case, it stops the loop, so it doesn't check the rest of the names, and then it adds the score. And the position it's trying to add it is the loop index. Since we've counted up to Pop, that loop index is going to equal to 2. Now we're going to go through the addScore loop. The first thing it does is loop from 9 to 0. This means we start from the bottom, which is important. Any score below our new score should be shifted down. We do this by making each score copy the score from above. So from the bottom up to Pop, we're going to copy each score from the score above. Then we replace Pop with our new score. So now we've effectively moved all scores downwards and put P where Pop used to be. In this example, we can see this happening live. Whenever I press the button on the orange cabinet, a random name and score is generated and then added to the list. And when a score is generated that is lower than every other score on the list, it simply doesn't add it, because it can't find any position that has a lower score. So that's a simple way of editing an array. But now we're going to answer how do you get one in the first place and how is it formatted. And for that we're going to turn to JSONs. JSON stands for JavaScript Object Notation. It's a way of formatting data based on how JavaScript writes objects. And even though it started in JavaScript, it's now used everywhere because it's simple and easy to read. Basically, it's just text that follows some rules. Construct3 comes with a JSON object, but for most use cases you don't need this. Unless you want to get hyper specific about how you're editing your JSON files, Construct has native graphical user interfaces for this. For instance, if you go to your project files and press new array, you can create and edit a JSON array without ever learning the format. This is because Construct3 handles the formatting for you, meaning you can input and edit data on a simple spreadsheet and have a professionally formatted JSON file made for you. However, I do have some examples of where you might want to use the JSON object. In this first example, whenever you hover over any of these objects, it will get that object as a JSON. The JSON object will then pass this information and return it as a beautified string. As you can see, this string contains data such as the X and Y coordinates for an object, the width and the height, the layer number, the Z index, and so on. This allows you to get a lot more data out of an object than you usually can with Construct. And although this isn't useful for most games, for niche cases it can be very helpful. For instance, the green object in the middle has a mesh on it, and you can't get the data for that mesh using regular events. You have to get the object as a JSON to even access this data. And whilst you don't need the JSON object to do this, it does make it easier. Next up we have arrays, like we were looking at before. You can see here the spreadsheet format that's being used within the Construct editor, and on the left you can see the JSON version of it. This is labelled C2 array, which I found funny because I think that means Construct2 array, I wonder if that's left over so that there's compatibility, or if it was just something they forgot to change. Either way, displaying an array like this and editing it is not super useful, but you can do so. The script below shows that you can modify an array using its path and changing some data. You can also add to a numerical value for an array if you know its path. But this is advanced information and you don't really need to use it, because Construct3 has a variety of actions that can edit arrays and other data sets without needing to know any JavaScript at all, even if it is just the formatting. Next we have save data, and this one can be useful if you need to know certain properties of your project, perhaps for Steam data. Say you wanted to know if a player had done a certain action so that you could give them certain achievements and such. Or perhaps you want to be able to check for a modified save file to do quickie save manipulation like Undertale or Doki Doki Literature Club. This is all to say it's relatively advanced, and generally you won't need it for most projects. Still though, it's interesting to look at. If you look at the example in the middle, you can see a JSON text format for save data. Here we can actually find the object data from the right. See, I've taken a screenshot from Construct. This square here has the UID of 3, and if we find that within the JSON, we can find that object's width and height, its position, and lots of other data on it, and this will be true for all objects in the project. Finally, we have what I think is the most useful case for using JSON files in your project. So if you're writing a game that has a lot of text, you might want to have multiple languages. And what JSON files allow you to do is store files within your project and use the same code to read them, and these files can have completely different text in them. In the example shown here, I have a short conversation in English and in French. You can press these buttons to load them in, and it's using the exact same script to read the actual file, it just loads a different one in based on which button you press. Now this is a super useful way for doing text, because you can go into the event sheet and hard code typewrite this, typewrite that, but then you'd have to go back and do it all again for different languages. But let's let you write line after line and use just simple code to read every line, rather than having to hard code every line in. That's it for this video. Thanks for joining me, and I hope I covered everything you wanted. If you have any questions or want to share some work, come join the Discord. If you like the video, give it a like, subscribe for more, and I'll see you in the next one.